Okay, this section is about finding the zeros, and off to the side I kind of just labeled different ways that we could technically find zeros. Not every way works. The first one is when you take the p over the q, when you factor the p's and the q's, and make as many fractions as you can and put plus and minus on it, and then test in the calculator. So that one right there, that works for polynomials. So that basically means it works on anything that has any exponent. Factoring is another thing that we've done in the past to find the zeros. Factoring is where you do all that stuff to rewrite it in parentheses, then you set it equal to 0 and solve each parenthesis separately. The thing about factoring though is sometimes things don't always factor, so it doesn't always work. And then another way that you can do it is by just looking at the graph. If you want to find zeros, you can graph it. You can use the G solver and then look at the roots to find those zeros. So in this chapter, we learn, since it's polynomials, I'm going to do the PQ stuff. So this is P, this is Q, Q is 1. So for the P factors, the factors are 1 and 8, 2 and 4. That's the entire list. And then Q is, let's see what we got here. Oh, Q is just 1. So we list the factors, the possible factors of P over Q, using every possible combination of P on top of Q. So it's 1 over 1, so that's just 1. And then it's 2 over 1, so that's 2. 4 over 1, that's 4. And then 8 over 1, that's just 8. Then we go back and we put a plus and minus on all of them. Plus and minus, plus and minus. So what ends up happening here is, if this is x to the third, that means we could have up to three zeros. So what we do with that information, we just plug it into the calculator. Minus 8, x squared, plus, and then minus 8. So we just go through and start testing, see, plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. That's a total of 2, 4, 6, 8. There's 8 things we have to type in the calculator. I've already done it ahead of time, and it looks like if you put in 8, it looks like 8 is the only solution that's going to give you 0. So if you plug it in and it gives you 0, then that's your zeros. 0 is x equals 8. So this is x to the third, and it was supposed to have 3, so what happened to the other 2? If you go and look at the graph actually looks something weird, kind of like this. Over here at 8, it crosses through, and then down here it does some funky stuff. So it only has one solution. The other 2 solutions, they're just imaginary. So this is the only answer we can get out of this. Second problem, same deal. This is P, and this is Q. Q is the leading coefficient. P is the constant term. So the factors for P, factors for Q. So for P, it's the 27. So we got 1 and 27. We have 3 and 9. And that's the entire list. And then Q is just 1. So we make all possible combinations. 1 over 1 is 1. 3 over 1 is 3. 9 over 1 is 9. And then 27 over 1 is 27. And then we just put plus and minus on all of these because we don't know what the sign's going to be. So we go into the calculator. We type in this, and we try every single number that's there. I already did this ahead of time. It looks like the only answer that's going to work is 3. So when you plug in 3, the answer is 0. So that means that x equals 3 is the solution. This one right here, we can do it the same way. Here's P, here's Q. So the factors of P, 1 and 4, or 2 and 2. So I'll just write 2. I don't have to write it twice. Factors of Q, 1 and 2. So when we make the possible list of P over Q, we do 1 over 1, so that's 1. 2 over 1, that's 2. 4 over 1, that's 4. So I've already used everything with this one, so I move on to the next one. 1 over 2. 2 over 2 is already 1. We already have it right here. And then 4 over 2 is already 2, so we already have that. So these are all the possibles, and then we just put plus and minus on all of them. And then we test them in the calculator. And again, this has an exponent of 2, so we could have up to 2 Or we might only have one. If they're all imaginary, or if one of them is imaginary, we might only find one. It looks like if you go into the calculator, plug in 2 parentheses squared minus 7 parentheses minus 4. Looks like there's actually 2 possible answers that would work. It looks like if you put in 4, this would give you 0. So x equals 4 is one of the zeros. And then it looks like if you also went back and tried 1/2. 1/2 is another one. Actually, negative 1/2, sorry. Negative 1/2 is the other one that also would give you the 0. So we get x equals negative 1/2 as the second 0. Next question. We can do it the same exact way again. Here's P. Here's Q. P is always the constant term. That means it's the one that doesn't have the letter. Q is always the leading coefficient. That means when it's in order from the highest exponent to the lowest, Q is the number in front of the highest exponent. So the list for P, 1 and 48, 2 and 24, 3 and 16. Actually, I have to scoot this over a little bit, I think. Try to scoot these over. Need some more space. This one around. Here we go. 1, 2, 3. Put the 16 right here. 4. 4 and, let's see, 4 times 12. And then 6 times 8. So we're really squeezing them in right here. Just scoot them over some more. So 16, back to 12, back to 12, 6 and 8. And I think that's the entire list. The Q. So for the Q, we've got 1 and 3 only. So we're going to take all the ones in red and put them on top of the black ones. So 1 over 1, so this is our P over Q stuff. 1 over 1 is 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 over 1, 12 over 1, 16 over 1, 24 over 1, 48 over 1. And I hope no one walks in on me talking all weird. Okay? And then we did all the fractions with the 1 on the bottom, so we're going to make every fraction with the 3 on the bottom now. So this is 1 over 3. Well, I'm messing up. Yeah, 1 over 3, 2 over 3. 3 over 3 is 1, so we already have that over here. 4 over 3. 6 over 3 is 2. We already have that one right here. 8 over 3. 12 over 3 is 4, so we already have that one. 16 over 3. 24 over 3 is 8. We already have that one. 48 over 3 is 16. We already have that one. And then we do the plus and minus of all this stuff. Plus and minus, plus and minus. So I'm not going to lie. Sometimes these problems get ridiculous, and there's probably a better way to do it. So we would actually have to test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We would have to test 30 different numbers in the calculator. So obviously that's not the best bet. Looking at that problem, I bet we could do it by factoring, or you could also do it by graphing. So this one, this is a waste of time. I would rather try factoring. So if we just factor out the 3, we get x squared minus 16. And then if you just do the difference of squares, this is x plus 4, x minus 4. We have the 3 in front, so we just set that equal to 0. So we end up with x equals negative 4 and x equals positive 4. We don't care about 3 because it doesn't have an x, so these are the 2 zeros. So again, guys, that's why you got to know all the different ways. Sometimes one way is better than another. This one, if we were doing the P's and the Q's, we would have to test 30 numbers to find the 2 answers. And the last one, heck, let's see if the last one can factor. I don't even know. Should have done these ahead of time, but whatever. So this looks like a simple ABC. Simple ABC. I believe a simple ABC is when you take the negative 20 at the end and make the list. Oops, that's not 12. It'll be a 20. So we get 2 and 10, 3 and 4 doesn't 4 works, 4 and 5, and that's the entire list. Trying to make the 1 in the middle, so it's 4 and 5. Now because this is a simple, we can go directly. Oh, I got to put the signs. I got to get negative 1 first. So plus 4 minus 5. So I can put plus 4 here and minus 5 here. And since this is an x to the 4th, we just take the x's and split them evenly. Also, you'll also notice that these blue x's, they always match the middle x. So it doesn't look like we can factor anymore, so we just set that equal to 0 and solve that. So x squared plus 4 equals 0, and x squared minus 5 equals 0. So we would have to add 5 to both sides. So x squared equals 5 square root. So x equals plus or minus 5. And then this one minus 4 minus 4. X squared equals minus 4 square root. X equals plus or minus, looks like that would be 2i. If the question says find all zeros, then we would write all 4 of these. But if it only says the real zeros, then we would only focus on this one. But if it's all zeros, we would list all 4. It says, what's the minimum degree of a function that has 4 real zeros? Well, if it has 4 real zeros, that means that it has to at least say x to the 4th. Now these next ones are nice because they've already factored them for us. It says, what are the zeros? So just set each one equal to 0 and actually solve it. So one 0 is 1, the other 0 is -2, the other 0 is 3, the other 0 is -4. So it's already factored, you might as well just solve it that way. Here's another one, but again, it's not completely factored. This one can be factored more. It's a difference of squares. X plus 5, x minus 5. And then this one can't be factored because that doesn't work on a plus. So x squared plus 16 is that one. So then we set each one equal to 0. So this is equal to 0, this is equal to 0, and this is equal to 0. So for these ones that are first degree, just solve them like a regular. So x equals 5, x equals -5. This last one we have to actually do work. Subtract 16, got x squared equals -16, square root, and then x equals plus or minus 4i.